Hello, everyone. Welcome back. This is section 1.2, wherein we are going to talk about the real number system. The real number system was also introduced to you or shown to you in Math 9. Perhaps some of you would be able to remember. So, having said that, let's take a look. This is page 12. Write each number as a fraction in lowest terms, then use improper fractions whenever appropriate. Okay. Um, so for that would be a fraction in lowest terms. So that would be 4/1. Oh, sorry. A number that uh, is being turned into a fraction, if it was a whole number, can always be given the denominator of 1. All right. This one is -6/1. Right. What about this one? 0.7. Well, in terms of place values, you may want to recall how you would call this when you were in elementary. I think that's 7/10, and by being able to tell yourself 7/10, you just created the fraction for yourself. Well, 3.6 is 3 and 6/10, but then the instruction tells you to use improper fractions whenever possible. So that means 3 and 6/10 would be 36/10. While 0.3 with a bar on top, I know that you guys would know that it's 1/3. Okay. Although the question is, do you know why it's 1/3 and where it came from? I mean, where's the math? In the past, I know that some kids would struggle with how to make 0.3 with a bar on top, which means it's a repeating decimal into a 1/3. And if we have time, I'm going to show that in class. All right. I don't want to do that in this video, otherwise it will take too much time. Okay. Here we go. Next. Which of these radicals are rational numbers? This is on page 13. Which ones are irrationals? How do you know? Well, a rational number, as defined in Math 9, is any number that can be written as a fraction. Okay. Therefore, if it cannot be written as a fraction, it is an irrational number. Okay. So this one, the root of 100, what would it be? Well, what is the root of 100? Well, root of 100 is 10, right? And you can turn 10 into a fraction by giving it a denominator of 1. Therefore, this is a rational number. So this one, rational, all right? Um, I will circle those numbers with in black if it was a rational. I will use a oh, I will only circle those that are rationals. The ones that I will leave um, uncircled will be irrational. Okay. Cube root of -25. Well, that is irrational. All right. You can't write that as a fraction, even if you try using it using a calculator. Root of 2.25. Well, that actually has a square root, 2.25, and that would be 1.5. And 1.5 would be can be written as 1 5/10 or 15/10. Therefore, this one is also a rational number. What about root of 2/18? Wait a minute. 2/18. If we just deal with the fraction first, we can simplify it into 1/9. 1/9 has a square root, which is 1/3, right? And this one is a rational number. Root of 12 is irrational. The cube root of -125 is -5 because -5 times itself 3 times will give you -125. And -5 can be turned into a rational number by giving it a denominator of 1. Therefore, this one is rational. 3/15, yeah, this one right here can be simplified into 1/5. However, if you get the root of that, you cannot come up with a fraction, so that one is irrational. Okay? All right. The real number system is composed of different sets of numbers. Now, in elementary, you guys were actually exposed to this one. In Math 9, you guys were told about this one. However, you probably would have forgotten. That's why it is a good idea to redo them at this time. What are natural numbers? Well, natural numbers are um, were known previously as counting numbers when you were in elementary. So the set of natural numbers will be all those counting numbers that you have: one, two, three, four, five, and so on and so forth. Now, what are whole numbers? Some kids would say that, oh, whole numbers are the counting numbers. Not really. The whole numbers, the set of whole numbers would actually be all of the counting numbers, but you have to include zero as well. All right. So as you can see here, the set of whole numbers would be all of the natural numbers, but zero was added. So in terms of if you were to make it a little more concrete, the natural numbers, the set of natural numbers can be found inside the set of whole numbers. All right, the set of whole numbers is a bigger set. What would be the set of integers? Well, that would be all the whole numbers and negative counting numbers in terms of how this book defines it. Okay, this would be the set of whole numbers and then the set of negative counting numbers. I don't really say it that way. What I say to introduce the idea of integers is this: the set of integers would be all of the counting numbers, one, two, three, four, five, and so on and so forth, and their opposites, the negatives and zero. Does that make sense? So that's just another way of saying it. But I mean, sure, if how the book says it is what makes sense to you, I'm fine with that. A rational number, just like what I said earlier, can be written as a fraction, a over b. This is a form of a fraction wherein there's a numerator, certain number a, and then there's a denominator, a certain number b, such that the denominator b cannot be zero. Otherwise, it's going to be undefined. All right. So again, these are just examples of rational numbers wherein they were all of these numbers can be turned into fractions. Okay. So this is the diagram in the next page. All right, which sort of illustrates further the connection between rational numbers and irrational numbers, and altogether they are referred to as the set of real numbers. Okay. All of these are the real numbers. Okay. So taken together, all of these would be the real number system. Okay. Now, what's inside? So it's sort of broken down into two parts: the set of rational numbers and the set of irrational numbers. Now, why is that? Well, the set of integers, well, I forgot to say that at the beginning. All of the natural numbers, right, can be found inside the set of whole numbers. It's just that the number zero is added. Now, the set of integers would be all of the natural numbers, all of the opposites, and zero. Now, all of the integers can actually be given a denominator of 1 and make it a fraction. That's why all of them are rational numbers. All right. So, however, the set of rational numbers are not limited to just the integers, the whole numbers, natural numbers. Why? Because this set of rational numbers also includes those numbers that are repeating and non-terminating, right? Like the 0.3, like what we had earlier, 0.3 with a bar on top. That's not an integer. That's not a whole number. That's not a natural number, and yet it's a rational number because it can be turned into 1/3. Okay. Now, if it is not a rational number, it is an irrational number. That's the idea. Now, with this diagram, the only thing that I don't like about this diagram, and I'll repeat what I said, the only thing that I don't like about this diagram is that the set of irrational numbers appear to be smaller than the set of rational numbers. So, like this sort of box is smaller than this box, when in fact in higher math, the set of irrational numbers are actually bigger. It's actually bigger. Okay. Uh, so I think I'll stop there for now. Otherwise, it's going to be a very long video. So just take some time and maybe you can take a break before you do the check your understanding. That's it for me for now. I'll see you again in a bit. Thanks. Bye.